Good morning. I'm posting your last notes for this week. You're going to have the 3 assignments on Pearson. And if you have any questions, just let me know. We're going to go over a few of these trig identities, and I'm going to show you how I formatted your assignment, so hopefully it makes sense. All right, so on your trig identities assignment, you have a couple things that you're going to do. The first thing is you are going to use trig identities to verify integer values. So if simplify to an integer. So what I've done is I've given you one of the Pythagorean identities, the sine squared plus cosine squared, or 1 plus tangent squared, or 1 plus cosecant squared. Okay, so we have here, or 1 plus cotangent squared, excuse me, that tangent squared, let's change that. Let's make this cosecant squared of 3 alpha minus cotangent squared of 3 alpha. So there's no leading coefficient, so I have to figure out what trig identity that relates to. So I'd go back to my 5.2 notes part 1 that I've given you, and I look at the trig identity. The trig identity that's associated with is, let me find it here. Is 1 plus cotangent squared equals cosecant squared. Equals cosecant squared. And of course the value here, it's going to be whatever angle it is. Now I want you to notice that those are the same. Because they're the same, that's essentially like having an x there. So I solve, and I want cosecant first, so I'm going to subtract cotangent squared because I need cotangent subtracted. So then that tells me that cosecant squared minus cotangent squared is equal to 1. So I would put 1 there, and that is my answer. Okay? Now if I gave you 3 cosecant squared of alpha minus 3 cotangent squared of alpha. We just talked about how cosecant minus cotangent is 1. So if there's a leading coefficient, you factor that out first. So you have 3 times the cosecant squared minus the cotangent squared of alpha, which then gives us 3 times 1, which is 3. Now in your homework, I only ask for the answer, not the work, so you would just show me that. All right, so let's look at this one. Let's say we have 7 tangent squared minus 7 secant squared. And we'll make that of lambda. So that's called lambda there. You'll see it spelled either BDA or LMADA. LAMDA. You'll see it spelled either of those 2 ways, and that's okay. So I look at the trig identity that's related to. 1 plus tangent squared equals secant squared.
Watch the Cheetos fall out and then play with your sand.
All right, so tangent squared is first. So what I'm going to have to do is I'm going to have to leave tangent and move everything else. So I'm going to subtract secant squared. So you have 1 plus tangent squared of alpha minus secant squared of alpha is equal to 0. Then I subtract the 1. So I have tangent squared of alpha minus secant squared of alpha is equal to -1. Once I have it in the form that I want, then I'm going to complete the rest of the steps necessary. So I'm going to factor out the 7 with tangent squared minus secant squared. I know that tangent minus secant is -1 due to my work, and then the final answer is -7. Okay, so you're going to take those trig identities, sine squared plus cosine squared is equal to 1. And of course, there'd be an angle there. You have 1 plus your tangent squared is equal to secant squared. And then you have 1 plus cotangent is equal to cosecant. So you're going to take those, manipulate those however you need to, and then factor and simplify. All right. The next thing that you're going to have to do is use those same identities to rewrite one trig ratio in terms of another. So we're going to have this here. We have that we want to write tangent theta in terms of cosine theta. So that means I want to know tangent theta equals what only in terms of cosine. So only cosine. So I'm going to rewrite this in terms of sine and cosine. So I have sine theta over cosine theta. This is good. This isn't. So I need to rewrite sine in terms of cosine. So I look at my identity. Sine squared of theta is equal to 1 minus the cosine squared. I only want sine, so I take the square root of both sides. So then sine of theta is equal to plus or minus 1 minus the cosine of theta. Now this is a positive tangent, so I'm going to use the positive form. So I have the square root of 1 minus the cosine of theta all over cosine of theta. That's in terms of cosine, that's in terms of cosine, so that's my answer right there. Okay, and I've put boxes in so you can show each of your steps, and hopefully I've directed you well enough that way you can write your answer correctly. So this is number 4 here. All right, number 5. Bye. Here we're going to do cosecant in terms of cosine. So I want cosecant of theta only in terms of cosine. So first I'm going to rewrite cosecant in terms of sine. This is not right because I need it to be cosine. I know that the sine is equal to 1 minus the square root of 1 minus the cosine. So then I rewrite it as 1 over the square root of 1 minus the cosine of theta. I'm not going to make you rationalize that, and it's cosine squared of theta there. I forgot to drop that squared down, so make sure you do that, and that's your answer. Okay? All right, let's rewrite cotangent of theta in terms of sine of theta. So First thing I do is write cotangent in terms of sine and cosine. So the cotangent is the cosine of theta divided by the sine of theta. Similarly to what we did before, we have the sine squared of theta plus the cosine squared of theta is equal to 1. So cosine, I want everything in terms of sine, so I'm going to solve for sine here. Nope, I'm going to solve for cosine because that's what I'm replacing. Cosine squared is equal to 1 minus the sine squared. So I take the square root of both sides to get cosine by itself. So cosine of theta is equal to the square root of 1 minus the sine squared of theta. I replace that. So I have square root of 1 minus sine squared of theta, all divided by the sine of theta. Okay? All right, let's rewrite sine of theta in terms of secant of theta. So this will be this is number 6. This will be number 7. So the sine of theta is equal to, so I want this in terms of secant, so the first thing I'm going to do is rewrite it in terms of cosine, because cosine and secant are related. So I have that sine is equal to 1 minus the cosine squared of theta. Now I can rewrite this in terms of secant. Secant is 1 over, cosine is 1 over secant. So we have 1 over secant squared. So then we have 1 minus 1 over secant squared of theta. Now for simplification, you usually don't want to leave fractions like that, so let's find a common denominator. So I rewrite 1 as secant squared over secant squared minus 1 over secant squared. I can combine those into one fraction, so I have secant squared of theta minus 1 all over secant squared of theta. Now, you could from there take the square root of the denominator, or separate it out, so secant squared of theta minus 1, which you can't take the square root of, over the square root of secant squared of theta is going to be equal to secant squared of theta minus 1, the square root of, over secant of theta. And there you go. That's the most difficult one. Whenever doing your homework, I would reference this to make sure that you don't have any issues. Okay? All right, now we're going to look at our trig identities. I'm going to show you how it's your homework's going to be formatted and how you're going to fill everything in. So if I tell you, and the instructions are going to say, simplify the right-hand side into the left-hand side. So we're going to leave the left-hand side alone, and we're going to simplify the right-hand side. So if I tell you to simplify tangent of theta times cotangent of theta equal to 1. First thing I'm going to do is I'm going to go to my identity sheet. And on your identity sheet, there is an identity there that says that tangent of theta times cotangent of theta is equal to 1. So that one's really easy because they're inverses. So then 1 equals 1. This is an identity. And that's your answer. So if it's an identity, that's all you do. All right. Let's look at a product that's not an identity. So sine of theta times cotangent of theta is equal to cosine of theta. So first thing I would have you do, I would have a step 1 there. And you definitely want to rewrite everything in terms of sine and cosine first. So in step 1, I'd probably leave sine of theta there for you. And then you would rewrite cotangent as cosine of theta over sine of theta. These will cancel. And that's the only step you need. So then the answer is going to be cosine of theta is equal to cosine of theta. Okay, so let's look at another product one here. 56. In your book, we have cotangent of theta times secant of theta is equal to cosecant of theta. Okay, so the first thing you would want to do, step 1, is rewrite everything in terms of sine and cosine. So you have cosine of theta over sine of theta. And I would give you 2 separate boxes for this, times 1 over the cosine of theta is equal to cosecant of theta. So then you simplify and you're left with 1 over the sine of theta, because the cosines cancel. It's equal to cosecant of theta. And then of course your answer is that cosecant is equal to cosecant. And that is that. Now I have listed each step there for you in your assignment because obviously I want you to show more of your work for this. So make sure you do that. All right, let's look at cosine squared minus sine squared of 2 theta minus sine squared of 2 theta is equal to 2 cosine squared of 2 theta minus 1. All right, when I look at this, everything is in terms of cosine squared, so I'm going to rewrite sine squared in terms of cosine squared. So I have cosine squared of 2 theta minus 1 minus cosine squared of 2 theta I then distribute the negative, and I did have you do that in a step. So cosine squared of 2 theta minus 1 plus cosine squared of 2 theta is equal to 2 cosine squared of 2 theta minus 1. At that point, you would add those and you have your answer. So 2 cosine squared of 2 theta minus 1 is equal to 2 cosine squared of 2 theta minus 1. Okay, so I look at my answer, look at what I need it to be in terms of. Since it's already in terms of sine and cosine, I can't switch that. So I look at the right side, it's in terms of cosine, so that means this should be in terms of cosine. And that's how I made that determination. So if it's only sine and cosine, that's what I'm going to do. Of cosine. Okay, so let's look at our next one here. So this would be number 12. We have tangent of theta plus cotangent of theta plus cotangent of theta times tangent of theta. So the first thing I'm going to do is I'm going to distribute. So this is step 1. So we have tangent squared of theta plus cotangent times tangent, which I'm actually going to rewrite as 1. If you didn't do that, it would be okay. And we want to show that that's equal to secant squared of theta. All right, anytime I see squared values, I'm hoping it's one of my trig identities. So tangent squared of theta plus 1. I come up here and tangent squared of theta plus 1 is equal to secant squared of theta. So let's see if that's what it's supposed to be equal to. It is. So then my answer is secant squared of theta is equal to secant squared of theta. Now, You could have technically had one more step after that if you didn't simplify. You could have, so this is optional here. Tangent squared of theta plus 1 is equal to secant squared. But if you knew that cotangent times tangent is 1, which I want you to know that, then you have your answer right there, okay? All right, let's take a look at this next one. 1 minus 2 sine squared of theta over 2 is equal to 2 cosine squared of theta over 2. So I'm looking here, the angles are the same, so that part doesn't matter. My answer is cosine, so I need to rewrite this in terms of cosine. So I know that sine squared is equal to 1 minus the cosine squared based on my identities. So this is an identity. Make sure you have that full list with you because it will help you tremendously when doing this. So my step 1 here is 1 minus 2 times 1 minus the cosine squared of theta. And that's minus 1 there. So the next step is to distribute. So I have 1 minus 2 plus 2 cosine squared of theta over 2, because it has to stay in terms of the same angle there. Theta over 2. And then it's simplifying from there, so then my answer is 2 cosine squared of theta over 2. 1 minus 2 is 1, so then we have that our identity verifies out. Okay? So let's do a few more of these, and then this will be your notes for the week. So on 14 here for our example, we have 1 minus the sine squared of theta times 1 minus the tangent squared of theta, I'm changing colors randomly, is equal to 1. So first thing you do is distribute. So I'm going to have that in 4 separate boxes, so I would want you to distribute 1 minus the tangent squared of theta, because then you have 1 times that. And then you have minus the sine squared of theta. And then I have minus sine squared of theta times cosine squared of theta. Or tangent squared of theta, excuse me. Is equal to 1. So I'm hoping all of this will cancel out. So I'm going to rewrite everything in terms of sine and cosine. So 1 minus the tangent squared of theta. Now I am going to keep in mind that this is a trig identity in case I need it. So identity here. Minus sine squared. Minus, and then I'm going to take my product here, sine squared of theta, sine squared of theta over cosine squared of theta. Okay. And that doesn't look like it's going to benefit me, so I'm going to do something a little different. So sometimes in trig identities, it's like a giant puzzle, okay? So what I'm going to do is I'm going to rewrite this as 1 minus sine squared of theta. So I'm going to pair these two terms together. And then I'm going to pair these two terms together because they both have a tangent in them and I can factor that out. So I'm going to rewrite that as negative tangent squared of theta plus sine squared tangent squared of theta. Okay, so then I have 1 minus sine squared of theta. I factor out a tangent squared, so I have minus tangent squared of theta. And then I'm left with 1 plus sine squared theta there. And this should actually be a plus here. So then this would be a minus. So be careful when you do your signs, because then obviously that would make it way more difficult for you. So that would be a minus. Now, this I know is an identity, is cosine squared. So I have negative sine squared theta over cosine squared of theta times cosine squared of theta and of course I've not changed this, and I know I'm probably not going to change the 1 because that's what I want it to be equal to, so I'm going to kind of try and keep that in its form as long as possible. So then the cosine squareds cancel, and I'm left with 1 hey baby, we're not going outside yet, baby. 1 minus the sine squared of theta and then I have minus sine squared here, and I've got to see about a sine. So let's check our work. So I want the sine squareds here to cancel, and because it doesn't, I need to see and check my work here. So I'm going to go back, check my distributive property, check all my signs. Oop. So 1 times 1 is positive 1, so that's good. 1 times negative tangent is negative tangent, that's good. Negative sine times 1 is negative sine. Negative sine times negative tangent is positive sine negative tangent. And that would be a plus here. And then if I factor it out, I would still factor out a negative, so that's right. And that would be a plus. So I factor out a negative tangent, which leaves me with 1 minus the sine. That changes to cosine. So I'm going to have to check this one, and I will post an updated video for you at the end of the week, because obviously I've done something incorrectly, and I have to check my work. So when you're doing that identities assignment, that's the one that's going to be the most difficult for you. Please, please, please text me, email me, let me know if you have any questions. And I don't care to post a video of how to do any of them, or just show you individually. If you text me and say, hey, I really don't know how to do this question, I can send you back some work for that. I look forward to talking to you next week.